Hello, in today's lesson, we are going to break down the algorithm for multiplying decimals by 0.1, 0.100, and so on. Similar to the process of multiplying or dividing decimals by powers of 10, such as 10, 100, or 1000, there is a well-established rule. To better understand this rule, let's work through an example. And it looks like this. 35,837.8 tenths I will multiply by 0.1 tenth. Of course, when multiplying a decimal fraction by a decimal fraction, I can use column multiplication, and let's multiply these numbers by column multiplication. So 35,837, 8.8 decimals. I'm going to multiply by 0.1. What do I get? 1 I multiply by 8, it will be 8. 1 multiplied by 7, it will be 7. 1 by 3, it will be 3. 1 multiplied by 8 is 8. 1 multiplied by 5 is 5. And 1 multiplied by 3 is 3. According to the rule of multiplication of decimals, we have to multiply without paying attention to the dots and then put the dots in our answer. To do that, we're going to count how many digits after our decimal point there are in our multipliers. So, there is one sign in the first multiplier and one sign in the second multiplier. Therefore, in our result, I separate the two signs I leave after our decimal point. The result is the answer that I write down, and that would be 3,500. 83.78 hundredths. Let's try and multiply that number again by 0.100. So that's 35,837. 8.8. I multiply it by 0.100. What is the result? Let's multiply it again by 100. So, what do we get? 35,837.8 tenths. I multiply by 0.100. When I multiply by 1, the resulting product remains the same. So multiplying 1 by 8 gives us 8, by 7 gives us 7, by 3 gives us 3, by 8 gives us 8, by 5 gives us 5, and by 3 again gives us 3. Therefore, we are multiplying the decimal numbers without considering the decimal point. And now, in the answer, we have to count the number of digits after the decimal point. So, we count one sign and here is 1, 2 signs. So I have a total of 3 digits after the decimal point. So in my answer, I have to emphasize these 3 digits. Write down the answer. It turns out 378 thousandths. And now, after multiplying by 0.1 tenth and 0.1 hundredth of the same number, I want to draw your attention to moving the decimal point in our answer. So, the decimal point in both the first example and the second example was after the number 7. Now notice in the answer, in the first example, we've moved the decimal point 1 digit to the left. And in the second example, our dot has moved 2 digits to the left. What do you believe this is contingent upon? The key idea is that in the initial example, we multiplied by 0 with a denominator of 10. This indicates that we had 1 digit after the decimal point. Therefore, our decimal point shifted 1 digit to the left. But in the second example, we have 2 digits after the decimal point. And our decimal point has moved 2 digits to the left, but in this case it is only 1. By multiplying by various decimal fractions, 1/10, 100th, even 1,000th or 1/10,000th, we can reach the conclusion. Ensure to maintain the meaning without modifying or omitting important details at any cost. I can utilize that particular rule, and let us proceed to apply that same rule now. And multiply the same number again, 35,837.8 tenths. I'm going to multiply by 0 whole ones. Let's take 1. 10 thousandths. What is the result in this case? Using this rule, the decimal point in my answer has to move by as many digits as the number of digits after our decimal point. So how many digits are there? 1, 2, 3, 4. So in the answer, our dot will move 4 positions to the left, 4 digits. 1, 2, 3, 4. So 1, 2, 3, 4. The solution is the number 3 in its entirety. 58,378 hundredths. By following this principle, it is prohibited to employ column multiplication. Instead, we must solely shift the decimal point in the resultant value. I would like to highlight the fact that dividing a decimal by 10 is important to consider. Or when multiplying by 0.1 decimal, our decimal point moves to the left. Why does this happen? Well, the point is that if I say 3.8 decimals divided by 10, when my decimal point shifts leftward, I end up with a value of 0. 38 hundredths. And if I multiply 3.8 tenths by 0.1 tenth, I also have a shift of our decimal point to the left. I obtain the decimal value 0.38. This is because I multiplied the decimal value 3.8 tenths by the decimal value 0.1 tenths. And when I convert 0.1 tenths to a regular fraction, it remains as 3.8 tenths. I am essentially multiplying by 1 tenth. In our scenario, I multiply 3.8 tenths by 1 and divide the result by 10. You and I have seen that if I divide 3.8 tenths by 10, that's the same as me multiplying by 1 tenth. So, I've written down to you that in this case, I'm multiplying 3.8 tenths by 1 and dividing by 10. That is why the same rule applies when dividing decimals by 10, 100, 1000, and when multiplying these same fractions by 0.1 tenth, 0.1 thousandth, and so on. In our next lesson, we're going to look at another rule that we're going to apply when we're dividing by decimal, 0.1 tenth, 0.100th, and so on. And that's all for today. Goodbye. See you again.